Hi, welcome to Main and 5WH channel at another very interesting topic about data visualization. As we all know, visualization is one of the very key area of programming or development or whatever you call. We have been seeing this at very different dimensions. Let me tell you my experience on visualization. So we initially started by very plain reports. Like reports were so important, we still continue it. Whether it's a financial report, inventory report, whether you're talking about a retail report, consumer reports. So reports of plain vanilla outcome which you get out of a data which is available on the system. So it still continues, right? So then people started thinking a report is very transactional, a report is very historical, but what about you trying to get details? So there were a lot of tools invented initially when I used to work with Oracle. There was something called report writer, a form writer. So interesting world at that point of time. They were so famous tools. Later part of life, if you really see, we invented tools like business intelligence. So BI basically is when you have large amount of data. So from the data you try to pull in a lot of information and then start presenting it back. So it's very historical in nature. So that's business intelligence. Then the world came in terms of projections, like what if analysis. So you had a lot of tools which is in the market, like BI tools. You had a lot. They were called enterprise performance management. No, you would have heard about Cognos. You heard about Hyperion. TPM is basically you give some input, it can do some projections. You're trying to really plan for the future. So you have historical reporting, you have you have kind of reporting which is basically for the future. Okay, and then there came a world of current processing. It means like when a business process is happening, can you really measure its performance? So you had a concept of business activity monitoring. Basically, we had a concept of BPM, business process management, where you had a tools like BPA where you can analyze and then you can process the data. You can actually write business logic with Beppel kind of model, and then you can actually measure. Like for example, if you're thinking of a simple scenario where you're looking at somebody is trying to come in a queue for visa processing within a country. For example, somebody is going, his port of origin is here, and then he's trying to get his visa in one of the country in US. Uh, when he arrives at the first place, there are a lot of people in the queue. Now, as they move on the queue, which is the business, you may want to create a lot of dashboard like so many have rejected, so many have accepted. So you don't wait for the history, you don't wait for the future, you're actually processing the current. So that's the kind of third element. So then the world changed into machine learning, artificial intelligence, data science, using statistics better, using R language. So we started inventing predictive analytics. Okay. So predictive analytics went to the next level of being prescriptive analytics. Not only you're trying to predict, you're also telling how to take action. So and then you start thinking like you get into deep learning and go neural analysis, blah blah blah. So the world has got a lot of changes in the last 3 decades, which I've seen practically, right? Now coming back to visualization. Now visualization is it's also been growing for years. So initially, if you remember, if you open an MS Excel, you can have charts, right? Now the charts, you have various types of chart, line chart, bar chart, you have pie chart. You can do a lot of analysis with the Excel sheet, right? So that was the first kind of visualization we had. And then people started thinking the visualization has to be deep. They started thinking the map visualization, geographical visualization. They start thinking, drill down reports, okay? People are now thinking like touch reporting, blah blah blah. So okay, so data visualization is a very important area because this is what a customer will see. Okay, so irrespective of whatever you use at the back end, maybe AI, ML, deep learning, you write a lot of data structures, but finally he will see. Like if you really see the Google map while it is transiting, so it's actually able to take you through a route. So that's also a kind of visualization of your really about your route. It's about the traffic, about your milestones, and then it can give you a lot of other kind of intelligence to it, right? So the data visualization topics have been there for a very long time. But today it has evolved into multiple things. Like every OEM has got tools for visualization. So in this topic, let me just share with you some of the interesting tools which is coming up on open source side, because I think all of you know, like Amazon will have good analytical capability, Oracle will have, Microsoft. It's not nothing rocket science, because they've been having a database now for years together. And these database had a BI component, they had an EPM component, then they had tried to look at Hadoop, big data, and now they have built in lot more reporting kind of frameworks inside the any software. So to me, if you have to learn data visualizations, you have to be pretty strong on data, pretty strong, understand what kind of patterns, and then really you have to know how to really visualize your data very well by trying to chart it. Okay. So the data visualization tools can present huge data sets on web-based platform, can be very tedious. Okay, there are a lot of frameworks and tools available for plotting data and for dynamic graph generation. Okay, so let's see some of the key features of a plotting library. So you can have a free and open source without any licensing. You can have program friendly drag, support for assorted web standards. You have animated charts. You can have integrated wizards and templates. You can have data imports from multiple sources, integration of application programming interface, responsive output, blah, blah, blah. So why do you use the real world scenario of desktop web based need different type of visual components, right? For user friendly interface. So some of the thing is sometimes you want to show the real-time maps and street views for mobile-based delivery system. For example, if you're using Zomato, Swiggy, Uber Eats, Amazon, you can see the real-time maps and street views and how the people are actually delivering your system. So that's one kind of web application. Second, you can see if you really go into stock market or health service or e-governance or commodity pricing or weather forecasting, you can see dynamic graphs and plots for predictions, right? And then if you go into machine learning and all, you can see knowledge discovery and predictive mining. So this is and there are a lot of popular free open source library for this. So I just wanted to discuss some of them today. Maybe you can really experiment and explore this. So one of the very famous thing which I've heard about is Candela, Candela. We'll see the tool shortly. Is one of the best open source data visualization package. It can be integrated into data science task for visualization using multiple programming interface, maybe JavaScript, Python, blah, blah, blah. So it's a very good tool which if you want to really expand, it's got box plot, box chart. I've used this personally, Gantt chart, histogram, graph level operation, tree heat map, scatter plot matrix, similarity graph. Okay, a lot of things available. Then another thing which is very interesting for me to really look at is d3.js. It's a free and open source JavaScript library distribution that is used to manage data of multiple dimensions. Okay, even big data sets can be plotted. The library supports data visualization through HTML, SVG, CSS, okay, and uses the DOM model. So d3.js is another after your Candela. And then if you go to sigma.js, I'll give you the URLs at the end in the presentation so that you can just click them and go and really experiment that. Sigma.js is a free and open source JavaScript based library for drawing of graphs, network, and dynamic plots. Okay, you have something called Flot. FLOT is a plotting library developed with the integration of jQuery and JavaScript. Okay, and dynamic graphs can be used like panning, zooming, redraw, tick labels. Everything can be done. Okay, you have something called Digraphs. DYGRAPHS is a flexible, fast library written is friendly with assorted web browser. You have something called leaflets. Okay, so there are so many of them examples. Let's just see few of them as a practical thing. Like if you really go first, let's understand what Wikipedia talks about data visualization. It's an interdisciplinary field that deals with graphical representation of data. It's a way to communicate when the data is, for example, a time series. From academic can be considered mapping between the original data and graphic element, and it has its root from statistics and therefore generally considered a branch of descriptive statistics. Okay, so that's what it talks about. And then if you really go in, it talks about some overview, characteristics, some quantitative messaging, visual perception, okay, terminology. So what's some examples? You can just go through this. I think I don't have to give a link for Wikipedia. You can just search for it. And then there are a lot of data representation architecture which has been discussed is into this, right? So So that's the first visualization you can get. Then what you can do is to really see the tools. So I discussed some of them. So Candela, what I just discussed, is an open source suite of interoperable web visualization components for Kitware's Resonant platform. It uses scalable, rich visualization available with a normalized API for use in real-world data science application, etc. So you have different components like lineup component, upset component, onset component, Vega visualization, GeoGS, geospatial visualization, blah, blah, blah. So you can actually check it out here. Like if you enter the following in the text named index, you can see that how it visualizes. You can really go through it. So this is one example. Similarly, you have Leaflet, an open source JavaScript library for mobile friendly interactive maps. So you can actually get a mobile friendly maps, and it's designed with simplicity. It can be extended with a plugin. It has got a well documented API, so you can just show you, like a lot of people are using it, like including Facebook, PI interest. Everybody is using. So it's behind the scenes which you should understand. Similarly, you have something called Data Wrapper. Now, Data Wrapper is quite famous. It uses 19 interactive responsive chart types, 3 interactive responsive map types. Okay, it's serving a lot of newspapers like New York Times, Ziet Online. So there is no code or design. You can just copy and paste, edit your chart, publish and embed. So that's another example. Then you have Float. It's a pure JavaScript plotting library for jQuery with a focus on simple usage, attractive looks, interactive features. Okay, it works on most of the browser, blah, blah, blah. So the thought process here is very simple. Why is this becoming very famous today is we are in the modern application world. We have applications which are really using data science, AI, machine learning, but the most important component of this entire application architecture is your visualization. So if your visualization fails, a user cannot really spot what you're trying to do. So hence, it's important for you to first align into your requirement, business needs, look at what kind of creative visualization you can do, and then identify tools, whether it's open source tools or if it is an OEM tool, which is the best for your project. Okay, so thanks for listening. We might have some hands-on on some of the tools as we go forward, but this is a good bird's eye view for you to get a picture about what is data visualization. Thank you.